So a bit of background on the project. Last year and the year before, the pre-emergent dactyl was taken off the market. This chemical was taken off the market just overnight. There was no real warning. And if you had some, you just recently bought some, they actually required you to take it back and hand it in. It sort of spooked myself and Dad. We started looking at robotic weeding and, I suppose, precision spraying. After looking into it for a little while, we came to the conclusion that it is well of our price range. These machines are quite pricey and they're targeted towards, I suppose, the big corporates and the, large-scale growers, of which I don't think there's probably many in West Australia that could actually afford to buy these machines. So we sort of like just left to the side. We're like, well, this isn't probably for us. We have to look at alternate means. Until when we started for maybe a couple of months, and then an article came out in the Veggies WA magazine. And it was an article talking about this bloke by the name of Guy Coleman, who spoke at Ag Evoke. And what Guy's done is he's produced what's called the OWL, which is the Open Weed Locator, which is a camera that you can mount to your spray bar, any typical sprayer, and it detects green on brown. So it picks up a green weed on a brown background. And then when it detects it, it turns on the corresponding solenoid or sprayer nozzle. So I got in contact with Guy and had a chat to him and was interested to see if he was interested in adopting these cameras for horticulture. Because the current cameras that he had were targeted towards broadacre. They'd spray a 250mm strip. And obviously for horticulture, that's a bit wide. We want 2.5 centimetre accuracy. And he said, yep, that's absolutely doable, and he was keen to work for us. So we're currently in the process of developing a green on green, so detecting a green weed in a green crop rather than green on brown. So it will go into what we're up to there. This is going to solve a few issues for us, I suppose, growers in Australia and the world. So the two major ones are, like I said, chemicals being taken off us. Obviously, dactyl is probably one of the first, but there's going to be plenty more in the future that's going to be taken off the market. And that's going to drive herbicide resistance. As we rely more and more on less and less chemicals, resistance is going to become an issue. So the way our system is going to help assist with the resistance side of things is we won't actually use chemical. Our plan is to use acids or bases, so something extremely acidic or something extremely alkaline to burn the weeds out when they're cotyledon or first leaf stage. The plan is at this point we're going to look at doing nitric acid. So nitric acid converts to fertiliser in the soil, so if you've limed your paddock or you've got free potassium, nitric acid reacted with calcium or calcium carbonate lime makes calcium nitrate, or potassium nitrate if there's potassium around. So the spots that have extra weeds are probably going to get extra fertiliser, as well as controlling your weed issue. These cameras or these machines will be extremely affordable. So the camera itself to build is extremely cheap. You're looking at under $1,000 per camera. And hopefully our plan is to have a 2-metre machine that will be coming under 50 grand. Maybe down to 20 grand per machine. So they'll be cheap to build and hopefully own. So they're also going to be affordable in the sense that you own your own data, or you'll be using open source data if things go well. And there's no subscription fees. So subscription fees are, I suppose, the hidden cost of these machines. They're quite expensive and they do add up. The idea is that we want to develop our system, these open source weeders, so that family farms can actually afford to adopt this technology versus, look at eco-robotics or carbon robotics, or what they call themselves, the laser weeders. You're looking at $250,000 to $2 million. It's unaffordable for smaller family farms. You won't be paying twice for the technologies. You won't be paying for the development and then the purchase. And if anyone is actually interested in these cameras, like I said, green and brown is already available. So you can go onto the website, we'll show you shortly. You can get the blueprints how to make them and build these cameras for green on brown. So in an orchard situation, if you just want to spot spray weeds under trees, or in potatoes, if you want to spray weeds before emergence, they'll work fine for that already. It's just we're trying to develop it more for in-field spraying, so in crop. Hopefully looking at developing our open source library, so which I'll go into that a bit further later. So on our trip, the main one that we saw, the main robotic weeder or precision spray that we saw was this one here, Eco Robotics. It's probably priced on the cheaper side of things for these sort of machines and works quite well. So you're looking at $250,000 for this machine, plus shipping if you're in Australia. And it runs a $10,000 subscription fee per year. That's for 3 crop types. For my situation, I've got 5 to 6 crop types, so my subscription fee would be, I'm not sure if it would be double, but I imagine it will be significantly larger than the 10 grand a year. The issue with things like the subscription fees is if you don't pay them, then you've just got an expensive piece of scrap metal because the machine won't work. And once you own the machine and they decide they got you by the balls, they can put the price up to whatever they want because you have to pay it, otherwise the machine doesn't work. So it's less an ideal situation to be in with those sort of machines. But they have got a lot of advantages. So starters, it works. So you jump in, you turn it on, you drive and it sprays. You tell it the crop, you tell it the weeds, and you drive and you spray and it works. These machines actually record while they're spraying and then upload it. And then within 24 hours, they update all the machines in the world. So they've got new models of software on them. So I've obviously got a lot of information getting fed into it all the time. They run multiple sensors on these machines. So this one here, each camera unit has, I think it was 6 different cameras. Had LiDAR for height, multispectral, infrared, a standard camera, and a few others. And what it does is it produces a 3D image of the terrain on the ground so that it gets precision. So yeah, it becomes quite precise and it doesn't miss. The biggest thing that the producers were saying from these machines was obviously the reduction in chemical costs because you're only spraying the weed. But the biggest thing why everyone had switched to them was the increase in yield. So most growers were seeing a 15% increase in their yield. And that's because, one, you haven't got the weed competition, but the bigger thing is these selective herbicides, whether it's a grass selective or broadleaf selective, they still have a negative impact on crop health and set your crop back. So if you can get away without putting these selective herbicides over a crop, I suppose you've got a healthier crop when you've got a high yielding crop. So that's where most of these growers were saying they were getting the biggest bang for the buck. There's very limited spray drift, if any, because you're spraying on an enclosed environment. So you can spray on a windy day, and days that you wouldn't be out with a boom spray, you can still get out with these kind of machines. And they move fast. So probably a slow jog to keep up with these things. So they pretty much, zip along. So these machines run 4 different algorithms. First 2 are generally how they run. So the first one is you're selecting for the weed. So you can tell it, these are the weeds I want, take these weeds out. And if that weed is located underneath or around a crop, you're free to spray the crop to kill the weed. So a lot of people would use this in seed production where they can't afford to have, I suppose, seed contamination. So they'd rather lose some crop to get the weed rather than save the crop. How the owl will probably work is they put a buffer around the crop. So imagine them as veggie seedlings. So the second image there, if a weed was located underneath a plant, underneath a crop plant, it would choose not to spray the weed to save the crop. And then you can use them for using crop only. So you can spray insecticide, fungicide, fertilizer, whatever you want, directly on the crop and nothing else. And then the last one, I'm not really sure why you need this one, but maybe applying pre-emergent, it's spray everything that isn't the crop. So maybe applying pre-emergent herbicides. I'm not really sure what else you'd use it for, but that's the other option. So disadvantages of these machines. They're big, So they only come in 6 metre or 6.75 metre spans. And the company said that they won't change those dimensions for anyone, kind of thing. So you want a smaller machine, they won't do it. You want a bigger machine, they won't do it. It comes as is, even though it comes in modules. This machine took 23 years to commercialise. Not really sure if it's a disadvantage or advantage, but yeah, so I've put a lot of time and effort into making this machine what it is at the minute. There's only 25 crops. They've only got a weed library currently for 25 crops. So if your crop isn't actually one of those crops, then this machine isn't for you. And for some reason, they all use non-selective sprays. So glyphosate was generally the one they'd choose to go through and spray the weeds out of the crop. Issue with that is if you got off-target spray, so accidentally sprays a crop with something like glyphosate, you hit a leaf, obviously systemic, it kills the whole plant. That's sort of why we're looking at using these acids or bases, because obviously our home-built machine isn't going to be as good as a $250,000 machine, so there's probably going to be some off-target application. So if you hit a leaf with an acid, you lose the leaf, but if you hit a leaf with Roundup, then you lose the plant. So it's another reason for trying to stay away from these chemicals. Return on investment. So this was a big one. So this is what the Christian, the rep, was telling us. You need 150 hectares of seed onions or 200 hectares plus of spinach seed to get an economic benefit from buying a machine and running a machine like this. So you need to grow a lot of hectares to buy that machine. And Christian was trying to tell us that there's only 300 farmers in all of Europe that were large enough scale to actually buy one of these machines. And I've nearly saturated the market. So they've nearly run out of market to sell these machines to, because they're too expensive pretty much. And it can't differentiate grasses. So if you're growing grass seed, it can't tell the difference between ryegrass and a fescue or something.
Thanks, Jake. So part of this project, a group of us through the Warren Cauliflower Group, if you're not familiar with it, it's a grower group started back, Gary, 80s, 90s? Quite a long history of growers. Predominantly started with growing cauliflowers to help improve the cauliflower industry in Manjimup. But that group still goes along, and Jake and myself are part of that, and many in this room. So part of what we did was a project where we were able to go to Copenhagen and the Netherlands. And on that trip, we went to do a day where we actually built these cameras that Jake's been talking about. So they're called the OWL cameras. These are all open source, available technologies that you can access. So it's not something you have to pay the subscription to access it. It's all free for anyone out there in the world to access. So we went to Copenhagen to meet Guy Coleman. He's been working at the University of Denmark over there to help farmers adopt this technology and find use cases, I guess, for it, because it's DIY friendly, it's relatively cheap, and as I said, it's open source, so there's no subscription models, and it's it's good entry level type equipment. So as Jake was saying, the cameras themselves are around about $1,000 to build. You're looking at about 4 or 5 components plus a 3D printable case. You can either buy those cases online, or if you've got your own 3D printer, you can download the file, print the case as well. So as I said, it's very user friendly, very optimized for DIY style. A lot of farmers, as you guys probably know, tend to like that style, build your own, fix your own. The right to repairs is quite a big topic as well. So this scenario is why I think Jake and Gary really were keen on it, and moving away from those high costs, high subscription models. So we'll probably just click on, Jake, if you want to click the GitHub instructions. All right, so feel free to ask some questions. It's fairly technical and we've got a bit of time. But there was some files at the top there just sort of showing you what you might need to do. But this page is developed by Guy. Is that right, Jake?
Yep.
So,
Guy developed this one.
so the guy has developed this page. It's on a free website essentially that you can upload anything you want. It's like a forum, I guess. So it's got the original format of the camera, which was aluminium cover where you had to buy that. Now it's 3D printable. Like I said, you can do that yourself if you want, or purchase it from someone who already has. Just slow down a bit while it loads. He's given examples of use cases there. So from really very technical ones as it loads, you'll see. So this is on the back of a ute. Someone's just rigged up a spray bar. I think there's 2 cameras. You can't quite see that there. So those 2 cameras with about 8 nozzles. So there'll be 25 centimeters spray spacings.
Yeah, 250.
Yep. And I'm assuming that system there would be for green on brown, driving along your like driveway. If you've got weeds popping up, you might just go along drive, or you into rows, that sort of thing. Because it's on the back of the ute, probably won't be driving in crops. Then it gets a bit more technical. So you've got an autonomous vehicle. So that's an existing technology that's already got the capacity to drive itself. You can, I guess, input the data on where you want it to drive. But the spray bar, I guess you would call it dumb technology, in that they don't talk to each other. The spray bar, all it's doing is seeing what the camera will see, something that's green, and it just tells the solenoid to turn on in that particular spot. So it's not telling the autonomous vehicle, oh, I see a weed over there, drive over there. The autonomous vehicle will just drive in a grid pattern, and then the spray bar will just turn on, off automatically, essentially. But yeah, they're not talking to each other. So they're just 2 separate technologies, but you can see how if you've got an existing piece of equipment, whether it be a tractor, motorbike, car, or autonomous vehicle, you can adapt this system to it. You don't, like I say, you don't have to outlay huge amounts of money, and it's very user-friendly, buildable yourself. The one on the end is what Guy built in Copenhagen. So I think it as an example, just to show how basic you can make it. But the third one I really like, I think we've got a slide later. Yeah, I'll talk about that one later. But yeah, like you can go crazy with it, or you can go really small with it. Just keep scrolling down. Also, the cameras themselves, they sit about 1 meter off the ground, and that meter means that you're seeing a square meter itself. And the way that they're calibrated is on about a 4 kilometer speed. And at that 4 kilometer speed, you get a 96% accuracy. As opposed to, say, 30 kilometers, you only get a 50% accuracy. So the faster you go, the lower your accuracy on those. You can mess around with them a bit. Oh, there you go. So there's an example. So the white boxes are the cameras. They are showing a meter. They've got 3 spray nozzles per meter. So they've got 0.36 or 36 centimeters that they'll physically spray. So it's quite a large area. But all you need to do is increase the amount of nozzles to bring your accuracy in. So more nozzles, more solenoids. And is there a limit, Jake, to how many nozzles per camera?
So the latest cameras that we're building up in Nanette can do 16 nozzles per camera. So its current one's only 4. Well, the original ones are saying you have to only make 4 nozzles per camera. So
what accuracy is that? 16?
That's 2.5 centimeter.
Yeah. So
yeah, of course, not space. You know, suspend can be probably all they're right on top of each other. They're 2.5 centimeters. So they're nozzles are. Yeah. So I think I'm a drawing on the actual spray bar.
And also remember, the camera's at 1 meter, but the actual spray bar is going to be lower. So you're not shooting 1 meter, 2.5 centimeters. You know, you might only be 1 foot or so, but you can.
So yeah, so that's the original design. And the design we're at, I think it's 0.5 meter. This camera's off the ground, and then it's 250 off the ground. That's a spray bar.
So the camera's 0.5 meter, so it gives you 0.5 meter.
So it gives you 0.5 meter view.
Yep.
But that's for the weed one. That's for the green on green. The brown on green is 1 meter. Yeah, the Spain bet will protect its spit on. That's the one thing we got to work around. I'm not really sure how we're going to fix that issue. Sprinkler to have leaks.
So there's still a few things to figure out.
Look, we're still well, hold the answer.
Just keep scrolling.
And also that camera,
Yep.
get it in a camera that way close to like the actress. Wait,
Yep.
Does have to be a more of a straight.
It's going to be a fan still like that. So
Any, it's going to spread out. How do you get it full?
that's why we put the buffer zone in, the safe zone around the plant. So
is that going to leave too much area? Not,
that's why you got to get them when they're young. So you look at spraying BG seedlings from the ages from transplant up to, depending how fast crop grows, 6 weeks old. And after that, you won't be able to use it because
there's no such thing as a band that, although it goes in a dead. You'll be able to, there's all different types of older set and added to it and the height.
So for what we need for our machine, we need a nozzle with a 4.5 degrees fan. Doesn't actually exist. So we actually use diesel injectors, stainless steel diesel injectors.
Diesel injector.
Yep. And I actually, sometimes you just got to get lucky, and we got lucky. Bought some diesel injectors out of China, $5 each, and just by chance, they actually had a 4.5 degrees plan pattern. So got lucky in that one, and it ended up being cheaper. I think we got quoted from Spray Line, I think it was, $450 for a nozzle solenoid, plus a nozzle on top of it. Or we could get diesel injector out of China for $5. That's nozzle and solenoid in one.
And stainless steel.
And stainless steel.
Yeah. So the beauty of the system is you can develop to your suited scenario, I guess.
Yeah.
So if you find that that accuracy is not good enough, you just got to find a way, like talk to Zach and get a better nozzle, or if it's too accurate, go a bit wider. That's the beauty of it. You can do it yourself. So we're talking about, I guess, Jake's scenario here, which is going to be specific to vegetables. But in orchards, it's going to be different. I guess you go much bigger. What else we got? So
I don't know. Really just...
So that's it. Yeah, that one there. So that's sort of what the camera will see. So I think it will show it later, but the actual camera will put a little boxes around the green. So when we're talking about green on brown, but all the brown it won't even pick up as a weed to spray. Keep going, and there should be a good bit. Keep going down. Sorry, Jake. On, yep. So these are all links. So if you do get inspired and you want to go home and do it yourself, grab the website and you just click on one of these, and this will give you the direct sites on where to buy the components. So there they all are. So there's quite a lot to it. Again, if you are au fait with ChatGPT, you probably use it to give you a bit of guidance. Otherwise, you're going to need to talk to Guy or give Jake a call. He'll tell you how to do it.
You'll do that. That's still free.
Yeah, I don't remember how to do it.
But there's also YouTube videos where he takes it through step by step. Fingers up the start there.
Yep.
Where you can just click on the video, you just go step by step, and we'll walk you through building it and then uploading the software.
Yep. So it's probably about all we need to see on the site, you reckon? So we've sort of spoken about this, but you can kind of see those boxes at the top. That's all the components you need for the actual camera. One's a Raspberry Pi. There's a camera itself at the end, some wiring, a little internal fan just to keep it cool. And if anyone's wondering what a Raspberry Pi, it's not a cake, it's a little computer. And it's basically just a very, very simplified computer. You can do some basic things like jump on a website or on the internet, but it's more for people who are interested or who can do coding and those sorts of things. So you can hook sensors up to them. You give it basic commands, essentially. It's not, it's not a super sophisticated computer or mobile phone or anything, but the components are really accessible and they're relatively cheap. And that's the beauty of these systems. So running a camera and then telling a program to spray a weed, it can do that sort of stuff. And it's going to be able to do the green on green as well. So to put all this together without any prior experience, it took us a group of what was it, 10 or 12 of us? Yeah, about an hour or so, again with zero experience. If you've got a bit of experience in it, you do it in 20 minutes, half an hour.
Realistically, you do building it, the hardware, 15 minutes.
Yeah, so it's not that long to do, but you're never going to be punching out lots of these things. You only need to do one or two in your life, or hopefully in your life. The thing that took a bit of time was uploading the software, and then it was it like downloading and then formatting, that sort of thing. Don't ask me how that works.
Again, it's on the website, but
yeah, it's on the website. And like I said, all under about $1,000. This is just per camera. And as we said, each camera is a meter. So if your booms are 6 meters wide, you're going to need 6 cameras. Or in Jake's case, it's going to be at half a meter. It's going to need 2 per meter. So that's, you know, a 6 meter boom, $6,000, or at half a meter, it's $12,000 just in the camera components. So it does start to add up over time. But if it's just the 2 meter, 1 meter height, it's pretty good.
all right.
Yeah, so we don't actually see the solenoid and the spray bar in this camera and this in here, but that like little computer will tell the solenoids. So
It's one of those green cheese, isn't it? Is where the solenoid connects to.
but if you've set it at a meter and you've got a square meter, your software has to be developed for, you know, which solenoid to turn on. So if it comes on in block A, block B, block C, block D, and it registers green in block A, it tells solenoid A to turn on. And then if it registers block C that there's green, it'll do that. Like I said, there was a group of us, all walks of life, all levels of experience, all ages as well, and not one person couldn't do it. No one came away not knowing how to do it. And you chat to Gary after this and ask him how he went. The thing we came away from was like, you know, if you can service your tractor or fix your pump or whatever, you know, you can build one of these things. It's just parts. You know, this talks to that, this connects to that. It's pretty straightforward. It's not rocket surgery. And yeah, as I said, you've got different levels. So I wanted to show this one here. So that's an autonomous vehicle. Like I said, they don't talk to each other. But Jake, if you've got the red pointer, you'll see on the ground there's green weed. And this one, what they've done is quite clever. They've put little lights on the solenoids. So it actually indicates when a solenoid's turning on. So in this scenario, it's not actually moving, it's just stationary, but it's the camera, the white box at the top, has registered that spray nozzle 2, or whatever it is called, has detected, in its zone, has detected green. So it's going to turn on that spray nozzle and it turns on the light as well. So it sort of just gives you a little indication on how it would operate in the field. And the example would be that that machine would be traveling at 4 kilometers per hour. It knows that at 4 kilometers an hour, it sees green at the very start of the in-feed of the camera. It knows to hold for 0.20 of a second before it opens the solenoid. It'll hold it for 0.3 of a second or whatever it needs to do to hit all that green, and then it shuts back off. So in theory, it's quite simple, straightforward, but in reality, like, it's a fair bit to get it to there. So that would be a 2 meter spray bar, 2 cameras. Yeah, and then like I said, the very simple generic one, probably wouldn't want to be spraying too many harsh chemicals with that thing. So, oh, and the other beauty is you can see the spray tank's pretty small too. So this is, I think, was this one in the Broadacre up in Gibson? This is his neighbours, I think. Salmon Gums, I think. So I'm assuming it's not doing massive amounts of work, but yeah, small tanker can do a larger paddock because it's only just doing little drips. Well, that's true, yeah. And so this scenario's got lights on it, so it can pick up the green. Jake's going to talk about this later as well, how light affects its accuracy too. So if you're doing it during the day compared to an overcast day or a really bright day, early morning, in the evening, you're going to get different accuracy rates. So having a cover sort of helps that with a light, artificial light. But again, for green on brown, it's probably fine. But when it comes to green on green, you need to really see how it works. Any questions on any of that, on how to build it?
So next steps. So we've got a camera, we've pretty much got the spray bar designed. The big thing with green-on-green technology is data. So to train these cameras on how to identify a crop and natural weed species, you need a lot of images. You need around 10,000 to 50,000 images per species for a camera, for the models to be trained with high enough accuracy to identify each individual plant. In the top right-hand side there, you can see that there is one image that's been annotated. So annotating is just pretty much going through and highlighting the crop. So in red there, you go through and you literally hand trace around the outside of the cabbage plant in this case. You tell it this is red cabbage. Then you hand trace around the green, which is in the wild radish, and you tell it that's a wild radish. And you do that for 50,000 different images. And each image took us about half an hour. So we did about 10 images and we're like, bugger this, we'll pay someone to do it. So I think AI ended up doing most of the work for us. And the reason why I need 10 to 50,000 different images is because you need to get it in different growth stages, different backgrounds. So the actual soil background itself actually impacts how these cameras detect these weeds. So if it's been raining and the soil's wet, it's darker, or if it's dry and the soil's dustier, or just different soil types, you got a red soil versus a brown soil, then it actually affects the way the camera sees the actual crop itself. So you need large data sets to actually get these models to work accurately. The original idea that we wanted to do to keep things cheap and easy was we'll just train it to identify the crop and tell it to spray everything else. Turns out you can't do that because it's the cheapest way. I mean, you just need 50,000 images, just the red cabbage, everything else is background, and we want it sprayed. Instead of doing, a million photos, you need ryegrass, clover, double G, fat hen, any other weed you can mention. Doesn't work like that by the sounds of it. You actually need to tell it, spray the red cabbage and don't spray these crops or these species. Otherwise, it gets confused and it starts misfiring and spraying crop. I don't know why, and Guy doesn't know why either. I think it's one of those things where the models don't always act. I think AI has issues with it too. Like they build a model and they don't actually know what it's going to do until you use it. And one thing they found out is you can't tell it not just to spray the crop, spray everything else because the machine gets confused. Yeah, so once you build a model, I think that's where AI comes into it, and the model then and you correct the model where it gets it wrong. Yep, so the camera will see everything the machine's going to be 2 meters wide, it'll view everything, and then, yeah, you got to tell it what it's looking for. The eco-robotics would be a machine like that would definitely account for things like that. What we're building, not really. Bottom left is how the actual camera itself is going to view it. So there'll be a buff on, that side, So it's going to tell it there's a buffer zone around the crop. So even if it identifies a fat hen plant underneath the broccoli, it won't spray it. So we're going to save the crop before it shoots the weed, and then obviously spray the weeds outside. And on the one in the blue drum, that's our first design of data collection. So light's very important for these machines. So consistent lighting is really important because, like I said, like any changes in the way that the camera views something confuses the machine. So if you can keep lighting consistent, you've taken one variable out. These are a few different systems we saw while we were in Copenhagen. So this was at a field day looking at, I suppose, precision spraying and robotic weeding. So the first one is the owl system on a spray bar. Now this didn't work very well at all. Because it's out on a spray bar and isn't under a cover, I think when the sun came out, it worked. And when the clouds came over, it just wouldn't spray anything. If anyone else actually builds one of these cameras, you'll see where you open the camera itself, you can adjust the hue. I'm not sure what it stands for, but it changes the way that it sees green. And as soon as light changes, the green's either brighter or darker, and it won't detect the level green that you told it to detect. So when you put it underneath a cover with artificial lighting, you're telling it, like, this is the colour green it's going to be all the time, spray this. But when you're out in open like this is, as soon as the sun came out, the clouds came over, you're changing the light, and it changed the way that camera viewed the actual crop or the weeds. got per plant there. So this is a camera that you just mount to the cab of the tractor. It looks in front of you and you input the size of your spray bar and it identifies weeds as they come up and then it turns on the solenoid. Same idea as the owl. Issue with this is that really had to be an obvious weed. So really fully grown, like a radish plant flowering in a wheat crop. It would go through it and it'll detect it. Couldn't really see, obviously can't see the small ones because it's looking at an angle, not down. And obviously if the crop's in the way, it can't see it. The four-wheel motorbike, that was probably one of the earliest designs of, I suppose, this sort of system. You'd go out, you drive the field, the camera then identifies the weeds, it GPS locates them, you then upload that to your GPS or your sprayer, and it goes out and it spot sprays those GPS locations. So that's probably a hard way of doing it. And the bottom one is just, that's per plant showing their systems on iPad. So you put the iPad in your tractor and that's where you control the camera from. Okay, so this is the spray bar. So still working on the design, but on the bottom left there is that's how the spray bar is going to be mounted. So it's going to run a common rail and the injectors that we're going to use are going to obviously plug into it. It's going to be one injector every 2.5 centimeters. That will give us obviously to the 2.5 centimeters on the ground for the spraying. One camera is going to run 16 of these. And the original plan was to have it mounted to some sort of autonomous vehicle. After talking to everyone in Europe, they're like, don't worry about autonomous vehicles, put on the tractor because you still need someone in the field manning the autonomous vehicle. They must be in the tractor looking at the crop and make sure the machine's working properly. So we sort of scrapped the idea for a robot and now we're back onto a tractor drawn machine. So yeah, like I said, it's going to be, this one here is actually 1.6 meters wide. So it'll be one of our beds. Haven't solved the issue of where your 2-inch pipes go. I think those rows will probably get left behind. Just have weeds around your sprinklers for now. Planting gap. Pretty much just got to finish getting these tech drawings done and then we can get it fabricated. Well, the weed library pretty much. So we need to collect and annotate the weed library, and then obviously implement it. And hopefully we'll have some sort of machine operating in March, we're hoping. So hopefully we'll have some sort of field day demonstrating the owl system working, as in spraying weeds, if not at least data collection. And I'd say at some point we'll have a workshop, probably looking start of next year once things get a bit quieter. I think most people are starting silage and planting and harvest soon, so might be best to keep it till March, April next year. We'll do a workshop, probably get a guy in for it via Zoom and demonstrate how to build these cameras and program them. And then hopefully at some point we'll get some sort of funding to do an open source weed library. But for now, I suppose the weed library will just be what myself and Dad do on farm, just to get our machine working. And then, yeah, it'd be nice to get industry involved to get an open source weed library to go with the open source camera. So any of us can build it, download the weed library off the same page and upload it. And then everyone can pretty much have a do it themselves open weed locator that will spray weeds out of our crop. But that could be further down the road, depending on, yeah, if anyone gets involved in terms of funding or whatnot. This here is a soil pit we saw in Copenhagen. This was pretty cool. Not really much to do with this, but they had this at the university. We are about 6 meters on the ground here, and they've got glass walls on each side with pH, soil, pH, EC, moisture, a heap of different probes, looking at different rooting depths and how different crops penetrate down the soil, affect moisture and whatnot. What was really interesting was they've got a topsoil that was at least 6 meters tall because there was no difference between the top and the bottom. It was just black soil the whole way down. So
Fertilizer mix they use.
what's the fertilizer mix on this one?
And just over there, what they use.
Oh, yeah, and these guys use like no fertilizer. I asked them about trace minerals. No one uses trace minerals. most of their fertilizer is free from the piggeries, and they just top up with a little bit of phosphorus and a little bit of nitrogen. And then they grow a 10-ton wheat crop.
NPK.
Yeah.
Nothing in between.
Yeah, because we'll ask, oh, do you foliar spray trace minerals? Nah, never heard of them. There's a few more photos from the field day. Oh, okay, yeah. So this was Horty World. So this was a university inside of a greenhouse that was also, was a demonstration building?
Yeah.
They take government officials there to show what Amsterdam's doing to the rest of the world in terms of their horticulture and whatnot. Never been so friggin' hot in my life. That building was hot. So I don't know why they put a university inside of these. I don't know how anyone studies, but yeah, interesting concept, but yeah, terrible idea.
And as you can see, this presentation was also given in Denmark. So
Yeah, to a bunch of Denmark farmers and consultants and university personnel. So, and yeah, just want to thank Overweight Locator and Guy, Veggies WA and FarmLink and VegNet for all their support. So obviously a lot of this would never have happened if it wasn't for them. So yeah, thank you.